On this video, I'm going to work through the problems from quiz 7. And they all involve finding the area by this region that I've shaded. It is enclosed by y equals 4x minus x squared and the x-axis. And there were 3 problems: rotate around the x-axis, rotate around the y-axis, and rotate around the line y equals -1. So there's the graph, y equals 4x minus x squared. Use Desmos, use your graphing calculator. Just make sure you get a graph. It's this region. This region is the same region in all 3 problems. Now, the first question is to revolve that axis, that region around this axis, the x-axis. So revolve about the x-axis. And there's a typical rectangle. It's a little thin x slice, dx there. I've drawn a vertical rectangle. And if I revolve that about the x-axis, then I will get a disc, a really small, thin cylinder. And the volume of a cylinder is pi times the radius squared times the height. So imagine this rectangle revolving around that axis. I'm going to get a disk. And so it will be pi radius squared. So the radius will be the distance from the center of revolution out to the function. So f of x, in this case, f of x is 4x minus x squared. Pi radius squared. Height, the height of that little disk is going to be dx. Add them up, take limits, integrate from x ranges from 0 to 4. Okay, so that was problem 1. Problem 2 takes the same region and revolves it about the y-axis. Now, you could, and I'm going to do at the end of this video, draw a horizontal rectangle and talk about how to solve it with the horizontal rectangle. That is way harder in this problem. It is much easier to take a vertical rectangle. Sorry about the cat is bumping the table and making the camera move. This vertical rectangle, if I revolve that about this axis, it's going to create a cylindrical shell. Excuse me. And the volume of a cylindrical shell, remember, is 2 pi, the average radius, the height, and the thickness of the shell. Right? So that's the volume of a shell. So in this case, it's 2 pi, average radius, distance from here out to the middle of that, we call that x. The height is the function value. The thickness of that shell will be dx. And add them up, take a limit, integral from 0 to 4. That is a whole lot easier than drawing the horizontal rectangle. So if I take this vertical rectangle, functions of x, and revolve it about that axis, I will get a cylindrical shell. Don't be afraid to use the cylindrical shell method. That makes this problem a whole lot easier than trying to use a horizontal rectangle. All right, I use the same rectangle. If I revolve that rectangle about the x-axis, I get a disk. If I revolve it about the y-axis, I get a shell. Really, the difference between a shell and a washer, the next problem has a washer in it, is that shells are tall and have a real thin dx for its thickness, and washers are real small, tiny cylinders. Okay, so this problem was now take that same region. The region does not change. The region doesn't come down Some confusion about, does the region now come down to here? It doesn't. The region is still just that region above the x-axis below the function. So if I take that rectangle and revolve it about that axis, I'm going to get a washer. And the volume of a washer is pi outer radius squared minus inner radius squared. And the height of the washer. So in this case, here's my center. That's where I'm revolving about. The outer radius is from here all the way up there. I already know that distance. I've used it a couple of times in here. That's 4x minus x squared. This distance, well, that distance is always 1. From here to there is 1 plus the distance from the axis to the function is that. So I got pi. The outer radius is the function plus 1, minus x squared plus 1. That's the outer radius squared. The inner radius is from here to there. It is always 1 in this problem, minus 1 squared. The height, remember this is on its side, so the height of that little washer is dx, and I'm going from 0 to 4. Okay, now the alternate way to do problem 2 is to try to do it with horizontal rectangles. And remember, if we use horizontal rectangles, we've got to solve this equation for x. We've got to get x equals. And so I'm going to get x squared minus 4x equals negative y. I essentially multiplied everything by -1 and swap sides, or just add and subtract. Either way, I'm going to add 4 to complete the square, add 4. This becomes x minus 2 squared equals 4 minus y. X minus 2 is plus or minus the square root of 4 minus y, and x is therefore 2 plus or minus the square root of 4 minus y. That is technically not y as a function of x, because I got two values here. I got a plus or a minus. But what I've got here, if you look at the graph, notice that the right end of the rectangle is on the graph, and the left end is on the graph. And it's got this center here. So really what we're viewing here, what we see here, is the right half of this function is the graph is the function x equals 2 plus the square root of 4 minus y. And the left half of this graph is x equals 2 minus the square root of 4 minus y. And that is hard to do. That's why I would suggest not doing that, but instead using the vertical rectangle with the shell. So now if I take this rectangle and revolve it around the y-axis, that little thin rectangle around the y-axis is going to be a washer. And so the radius, the volume is going to be pi outer radius squared from here over to the orange function. Outer radius is 2 plus the square root of 4 minus y squared minus the inner radius, distance from here to the purple function, 2 minus the square root of 4 minus y squared. That's the inner radius. The height of that little washer is dy, right? It's a thin slice on the y-axis. That's dy. And we evaluate, where does y range? Y ranges from the x-axis 0 to here, right? The maximum y value. The maximum y value occurs when, let's see, y prime is 4 minus 2x. That's when 4 minus 2x is 0. X is 2. And if x is 2, y is 8 minus 4 is 4. So it's also 0 to 4 for the limits on that. That is harder, I think, than trying to use a vertical rectangle.